Target lock, Hong Kong, China. Beneath this mountain, with a volume of over 2 million cubic meters, Asia's largest man-made cavern complex is about to emerge. What is this massive cavern for? And how did we achieve all this? This time, let's embark on a real-life mountain-moving project. This is a C919 aircraft, and this is the cavern we are excavating. It doesn't look that big, but in fact we're not excavating just one cavern, but a super cavern complex composed of 15 chambers, arranged in a 7 vertical, 4 horizontal pattern. Among them, the largest chamber has a sectional area exceeding 900 square meters. So, here comes the question. How was such a large chamber created? Excavators? Too slow. Tunnel boring machines? Too small. Then we can only use the most traditional method, blast. Thus, 2 smart tunnel drilling rig known as Jumbo were used by engineers from CSCEC. They possess 3 heads and 6 arms just like NESA. Sensors installed on their arms can collect data in real time to ensure the accuracy of the drilling operation. In just 3 hours, they can quickly and accurately drill over 200 holes. After drilling is complete, workers load explosives into the holes. Check, evacuate, detonate. This is known as a drill and blast method. However, a jumbo can only drill up to 13 meters high, which is not enough to cover a cross-section up to 32 meters high. Since one blast isn't enough, we'll just blast multiple times in sections. The entire cavern complex requires a total of 2,500 blasts. Yet, outside the cavern, the sound is barely audible. How is this achieved? The key lies in the method of detonation. The holes are equipped with high-precision delay devices. By controlling the delay time of each borehole, they are detonated sequentially. This way, vibration waves can be stacked and canceled out. Thus, the intense concentrated blasts are transformed into continuous micro-explosions. Coupled with blast doors and other soundproofing facilities at the tunnel entrance, the impact of blasting on nearby residents is minimized. But at this point, engineers face a second challenge: how to ensure such a large hole doesn't collapse. Perhaps we can consolidate the rocks. First up is fiber-reinforced shotcrete. It's sprayed onto the rock surface after blasting, filling cracks. Next comes the soul of the system, rock bolts. They connect the internal rock mass using friction between rocks to maintain stability. This is the bolt shotcrete method. Normally, the combined use of shotcrete and rock bolts is only a temporary method, but engineers found an ingenious solution. They encased the rock bolts in plastic pipes, and after tightening, injected cement grout both inside and outside the pipes. This creates 2 layers of anti-corrosion protection. Then, fiber-reinforced concrete is sprayed again for further reinforcement. Thus, temporary support is transformed into permanent support. Compared to traditional lining and requires reinforcing mesh and other structures, this greatly streamlines the process. But have you ever wondered, a 2 million cubic meter cavern means we need to remove 2 million cubic meters of rock. With so much rock, is there a better way to handle it than simply disposing of it? Of course. Engineers from CSCEC chose to crush it into aggregates, and then process it into concrete for recycling. Besides recycling the rock, they have also taken various measures, such as replacing diesel machinery with pure electric machinery, significantly reducing carbon dioxide emissions. By then, we had already relocated and excavated, creating Asia's largest cavern for civil purposes.